Hi everyone, today we are going to start learning about inverse trigonometric functions. Okay, so let's start by talking about what exactly an inverse trig function does. So let's start by looking at our sine function. So we know that for sine, our input is an angle. We'll call it theta. And then our output, it gives us a value. So for our inverse trig functions, which look like this, so this we would read as arc sine, but the notation looks like this. Please note that this does not mean sine to the power of -1. It's not the same as 1 over sine. This is the symbol for an inverse trig function. So for an inverse trig function, the x and y values, well, the input and the output mean the opposite as they do here. So for inverse trig functions, the input is some value, and our output is actually going to be an angle. So we use inverse trig functions when we're trying to figure out what the angle is. So it's really important to understand here our input is a value and what it spits out is an angle. So before we actually start working with these trig functions, I want us to try graphing them so we can really understand the specific domain and range, because for the inverse trig functions, they do have really kind of funky domains and ranges. So to graph arc sine, let's start by doing a quick sketch of sine. So here we'll sketch y equals the sine of x. So remember, we could just take a couple coordinates. Let's call this 1/2. So we can see it a little bit better. So we know that sine starts here. And then we just go 1, 2, 3, 4. And this is one full period of sine. And then we go 1, 2, 3, 4, and then this is another full period of sine. Okay, so for our domain for sine, we can see that it is all real numbers. And then for our range, we can see that we have a minimum at -1, and -1 is included, and a maximum at +1. So when we go to graph our inverse function, so here we're going to graph arc sine. Remember, we can graph it by taking these coordinates and we literally swap the x and y values. So let's just graph a couple. So we have 0, 0. We have pi over 2, 1, pi, 0, 3 pi over 2, -1, and then 2 pi, 0. And again, to graph the inverse function, we literally swap the x and y values. So here you can see I've swapped the x and y values. So 0, 0. Instead of pi over 2, 1, I have 1 pi over 2, and then 0 pi, -1, 3 pi over 2, and 0, 2 pi. So this is what that would look like. And then we can kind of continue this pattern right here. But then you'll notice that if we simply do this, we have a really, really big problem. If you remember our vertical line test, if you draw a vertical line, your graph cannot cross it at more than one point at a time. So this clearly fails the vertical line test, which means this is not a function. So what we do to adjust for this is we actually restrict the domain and range. So for arc sine, we only use a tiny part of this graph. And we're only going to use the part from here to here. So this part in red is actually the only part of arc sine. Everything above it and below it is not actually part of our inverse function. So you can see that they picked this region for a number of reasons. It does go kind of from a maximum to a minimum. And again, if we go from here to here, right, that wouldn't work because it's not a function. We can't really go from here to here because it's not a function. So this is the easiest way to cover all of the values while maintaining the function status. So if you look at what's in red, this function clearly has a restricted domain and range. So our domain is going to be from here to here, which is -1 to +1. Notice I rescaled my x-axis. And then our range is going to be from here to here, which is -π/2 to π/2. Okay, so you'll notice that the domain of arcsine is the range of sine, so that is not a coincidence. It's because we swapped the x and y's. However, remember our range we had to restrict so we could maintain the function characteristic. Again, if we went beyond that, it would fail the vertical line test, which is why we have to chop it off at this tiny little segment. Okay, so let's do the same for arc cosine. So let's take a moment. We're going to start by graphing cosine. So again, I can rescale my y-axis. So we start at the maximum, and then we go 1, 2, 3, 4. And then 1, 2, 3, 4. So we can see that the domain of cosine is all real numbers, and the range is the same as sine. It's -1 to +1. So now to graph arc cosine, we're going to do the same thing. We're going to swap the x and y values that we have from our cosine function. So I'll take these 5 and I'm going to swap them and graph them here. Okay, so instead of having 0, 1, I have 1, 0. Instead of π/2, 0, I have 0, π/2, so on and so forth. So it would look something like this. And then we can kind of continue that pattern here. But again, you'll see that we have that same problem. If we simply swap all the x and y values, this is not a function. It fails the vertical line test, which means we are going to need to restrict the domain and range to help us turn this into a function. So for arc cosine, again, we're only going to use part of this graph. And the part that we use is actually from here to here. So again, we are only actually going to be using this part in red. Everything else in blue above or below it is not actually part of arc cosine. So you can see again that we have a restricted domain and range. Our domain is from -1 to +1, just like arc sine. And then our range is from 0 to pi. So again, this was just kind of the most convenient way to cut our graph up so we can maintain that function status. Again, if I went from here to here, well, this wouldn't be a function. Okay, and now we're going to do the graph of arctangent. So for arctangent, we're going to start with the graph of tangent. So hopefully we remember that it has vertical asymptotes that occur at π/2, and then it repeats every pi units. So it looks like this. And then we have a point here at 0, 0, a point at π/4, 1, and -π/4, -1. And then this general shape is going to repeat in each new period. Okay, for the domain here, it is all real numbers except for our asymptote. So we can say all real numbers except for x equals π/2 plus pi n. So these include all of the asymptotes. And then you can see that our range is actually all real numbers. Okay, so to graph arctangent, we can start by using the asymptotes from the original function, and instead of being at x equals π/2, we're actually going to draw it at y equals π/2. And that means that we're also going to draw them we would draw them every pi units apart. Now, as we did before, if we kind of extend our graph infinitely and we keep switching x and y, you're going to notice pretty quickly that we don't have a function. So it would look something like this. So here again, I just took these original coordinates and I swapped the x and y. So I have 0, 0. Instead of pi over 4, 1, I have 1 pi over 4, and then negative 1, negative pi over 4. So you can see again, if I do this, this fails the vertical line test, and this is not a function. So really, the only part that we're actually going to use is this graph in the middle. So I'm going to do it in red. So this is the graph of arctangent. Again, this in blue and this in blue is not actually part of arctangent. So again, the way we adjust for this non-function is to restrict the domain and range accordingly. So here, our domain is actually going to be all real numbers, which not coincidentally is the range from our original function. And then you can see that our range is going to be everything between these two asymptotes, but not including them. So our range is everything from negative pi over 2 to positive pi over 2. So again, it's kind of similar to the range of arcsine, except these values are not included because, again, they are bound by asymptotes. So remember, this part of the graph is not actually part of our inverse function. It's only this one. We had to restrict the range so we could turn a non-function into a function that does not fail the vertical line test. So here's our graph of arctangent. Okay, so now that we have graphed our inverse functions and we understand that the domains and ranges are restricted for them, let's generalize some rules. How does this affect us when we are using these inverse functions? So the first rule is you can only take arc cosine or arc sine of a number that's between negative 1 and positive 1. Remember, this is the domain of these functions, so it's our input. So you can only input a number between negative 1 and positive 1. So if you're trying to input a number that's outside this domain, the value will be undefined. Our second rule, arc sine can only give you an angle between negative pi over 2 and positive pi over 2. So this is the range of arc sine. So if you use a calculator, it will physically only be able to give you an answer between negative pi over 2 and positive pi over 2. Again, that's the range or the output of arc sine. For arc cosine, it can only give you an angle between 0 and pi, which is the range of arc cosine, and again, range is the output. So you have to understand that these are different. Arc sine will give you either a negative angle in quadrant 4 or an angle in quadrant 1. Arc cosine can only give you an angle in quadrant 1 or 2. Okay, rule number 4 is that you can take the arctangent of any number because the domain of arctangent, remember, is all real numbers. So you can input whatever you want. However, the output or the range is restricted. Arctangent can only give you an angle between negative pi over 2 and pi over 2 and not including them. So while you can input any number you want into arctangent, the output is restricted to quadrant 4 or quadrant 1. Okay, so now let's see if we can apply what we know about our inverse trig functions to evaluate some expressions. So here we're going to evaluate 3 arcsine expressions. So before we do that, let's have a quick reminder. The domain of arcsine is everything between negative 1 and positive 1. That's what we can input into our expression. And then the range is everything from negative pi over 2 to pi over 2. So that's what we can output. Okay, so these rules will apply to all 3 of these. So for the first one, they want us to find the arc sine of 1/2. So essentially they're asking us sine of what angle equals 1/2. So this is within our domain, and then we know that this angle is going to be pi over 6, which is between negative pi over 2 and positive pi over 2. Okay, so now here we're going to find the arc sine of negative 1/2. So again, our reference angle for this would be pi over 6. However, we need to adjust it. Again, we can only be in this realm between negative pi over 2 and positive pi over 2. Let me label those. Here's negative pi over 2 and positive pi over 2. So if I'm taking the arc sine of a negative number, I know that it's actually going to be down here, a negative angle in quadrant 4. So in this case, our answer is negative pi over 6. So again, it's the same reference angle. We just have to adjust it so it's within our appropriate range. Okay, and for part C, they're asking us to find the arc sine of 3 over 2. So our domain is between -1 and +1, which means our input, this number, must be between these numbers. And we see that 3 over 2 is greater than 1. So this is not within our domain, so we would say that this is undefined. And if you try to plug this into your calculator, it will say domain error for this exact reason. Okay, go ahead and pause the video and see if you can evaluate these 3 expressions. Okay, so for part A, the arc sine of negative root 2 over 2 is negative pi over 4. So our reference angle is pi over 4, but we need to place it in the appropriate range, so we have to go backwards into quadrant 4. Arc sine of root 3 over 2 is pi over 3 because the sine of pi over 3 is root 3 over 2. This is in quadrant 1, so it's within our range. And the arc sine of -1 will give us negative pi over 2. So remember, the way we adjust for a negative value here is to go backwards into quadrant 4. Okay, so now we're going to try to evaluate a few arc cosine problems. So let's review again what the domain and range are. The domain, so our input can be any number between and including -1 and +1. And then our range is different than arc sine, so we need to be careful, is everything between 0 and pi. So this tells us if we need to create, if we have a negative value here, we need to adjust for that by entering quadrant 2. So our range is any angle from here to here. So this will be for positive values, this will be for negative values. So for the first one, let me label that really quick as well. Okay, for the first one, the arc cosine of negative root 3 over 2. So since it is negative, a negative value, I know that I am going to need to be in quadrant 2 to adjust for that. Cosine is negative in quadrant 2. And then I know that the angle, well, my reference angle would be pi over 6, so that means that this must be 5 pi over 6. Okay, let's look at this next one. Here we want the arc cosine of positive root 3 over 2. So since this value is positive, we can be in quadrant 1, and we know that that angle should be pi over 6. Okay, and last, here we have the arc cosine of 0. That is within our domain, so that value will be at pi over 2, because the cosine of pi over 2 is 0. Okay, go ahead and pause the video and see if you can evaluate these 3 expressions. Remember, you need to be aware of what the domain and range for arc cosine are. Okay, so for part A, since this is positive, it will be in quadrant 1, and the cosine of pi over 3 is 1/2. So that's our answer for part A. For part B, you'll notice that 2 is not within our domain because 2 is greater than 1, so this value is undefined. It's a domain error. And for part C, since this value is negative, we know that we will need to be in quadrant 2, and then the cosine of 3 pi over 4 is root 2 over 2. Okay, so last we're going to evaluate some arctangent functions. So again, let's review the domain and range. So remember, the domain for arctangent is all real numbers. So we should be able to evaluate any arctangent expression. There are only some that you'll be able to do by hand, but your calculator would be able to evaluate any other expression that's not a unit circle angle. And then our range, remember, is restricted because of those asymptotes. So remember, our range is between, but not including, negative pi over 2 and pi over 2. So again, we are going to be working somewhere either between pi over 2 and negative pi over 2. Those are going to be our answers. So it's either going to be quadrant 1 or quadrant 4 as a negative angle. So this first one, the arctangent of root 3 over 3, since this value is positive, we can be in quadrant 1, and the angle that has that value is pi over 6. So for the arctangent of negative root 3 over 3, again, since this is negative, we know that we will need to be somewhere in quadrant 4. And it's the same reference angle as the first example, but we just need to make it negative. So negative pi over 6. And last here we have the arctangent of positive 1. Since this is positive, we will be in quadrant 1 because that's where tangent is positive. And we know that the angle that yields that value is pi over 4. Okay, so here, go ahead and pause the video and give these last 3 a try. All right, for example 1, since this value is negative, we need to be in quadrant 4, and then the tangent of negative pi over 4 is negative 1. For part B, the arctangent of root 3, this is quadrant 1 because it's a positive value here, and that is 60 degrees or pi over 3. And then last, the arctangent of negative pi over 3 then must be that same reference angle, but backwards in quadrant 4, so negative pi over 3. Okay, that is all for today's video. Thank you so much for watching.